So, you've totally nailed linear equations, right? The whole straight line thing? Well, get ready, because today things are about to get a little curvy. We're jumping into the world of quadratics, and this is a huge step up. We're going to learn how to build them from scratch, break them back down, and even see what they actually look like. So let's dive right in.
Okay, take a look here. On the left, that's a linear equation. You know that guy. But on the right, that's a quadratic. So what's the big glaring difference? It's that tiny little power of 2 up there, the x squared. Seriously, that one little term is the star of our show today. It's the reason for everything we're about to talk about, and it's what gives quadratics that classic curved shape.
All right, first things first, let's get our vocabulary straight. It's super simple, I promise. When you see something like x squared plus 3x plus 2, we call that a quadratic expression. It's kind of just a mathematical phrase. But the second you slap an equal sign on there, like setting it equal to 0, bam, it becomes a quadratic equation. Now it's a full sentence, a problem we can actually solve.
So, how do we even make these things? Well, before we build the whole castle, we need to know what the bricks look like, right? And in the world of quadratics, our bricks are called binomials. It's just a fancy name for a simple little expression with 2 parts, like x plus 1. Think bi like bicycle, 2 wheels, 2 terms. These are the Legos we're going to use to build everything else.
Okay, let's get to it. We're going to start by actually building a quadratic. We'll take 2 of those simple binomials we just talked about and multiply them together to create something way more interesting.
To do this, we use a super handy trick with a pretty memorable name, FOIL. Yeah, F-O-I-L. It's an acronym, and it's basically your cheat sheet for getting this right every single time. It stands for first, outside, inside, and last. It's our roadmap, so let's follow it.
Let's just do it together. The F stands for first, so we multiply the first term in each set of parentheses. X times x gets us x squared. Easy. Next, O is for outside. We multiply the 2 outermost terms. X times 2, which is 2x. Then I for inside. The 2 inner terms, 1 times x is just x. And finally, L for last. The last term in each parenthesis. 1 times 2 is 2. See? 4 quick steps.
Okay, we're almost there. The last step is just a bit of cleanup. You see those 2 terms in the middle, the 2x and the x? We can just combine those. 2x plus another x gives us 3x. And boom! We're left with x squared plus 3x plus 2. We just built our very own quadratic. How cool is that?
Awesome. So we know how to build them, but what if we need to do the opposite? What if we get a quadratic and need to break it back down into its original pieces? Well, that's called factoring. And here's the secret. It's not new math. It's just FOIL in reverse. Think of it like a puzzle.
Here is the absolute key to the whole puzzle. You're always looking for 2 magic numbers, and these numbers have to do 2 jobs at once. They have to multiply to give you that last number, the constant, and they have to add up to give you the number in the middle. If you find those 2 numbers, you've solved it.
Okay, let's try one. We've got x squared plus 6x plus 8. So, what's our puzzle? We need 2 numbers that multiply to our constant, which is 8, and add up to our middle number, which is 6. Take a second, think about it. What are the factors of 8?
All right, let's walk through the possibilities. We could try 1 and 8. Yeah, they multiply to 8, but 1 plus 8 is 9. That's not a match. So, what else? How about 2 and 4? Let's check. 2 times 4 is 8. Check. And 2 plus 4 is 6. We found them. That's our pair. So our original pieces were x plus 4 and x plus 2. Puzzle solved. So great. We can build them up. We can break them down. But why? Why are we doing all this? Well, this is the payoff. Factoring is the key that unlocks the actual solutions to these quadratic equations.
And these solutions, they have a special name. We call them the roots of the equation. The roots are simply the values of x that make the whole thing true, the numbers that make the equation equal 0. They're the answers we've been looking for all along.
Let's see it in action. To solve x squared minus 5x plus 6 equals 0, what's our first move? You guessed it, we factor it. We need 2 numbers that multiply to positive 6 but add up to negative 5. That means they both have to be negative, right? Yeah, it's got to be negative 3 and negative 2. So we can rewrite our equation as x minus 3 times x minus 2 equals 0. And now for the magic trick. Think about this. If you multiply 2 things together and the answer is 0, what does that tell you? It means one of those things had to be 0. There's just no other way. So either the x minus 3 part equals 0, which would mean x must be 3, or the x minus 2 part equals 0, which would mean x is 2. And just like that, we found our two roots. The solutions are 3 and 2.
Okay, we have totally crushed the algebra part. Now let's switch gears and see what these equations actually look like when we put them on a graph. It's time to visualize.
When you graph a quadratic, you don't get a boring old straight line. You get this beautiful, symmetrical, U-shaped curve called a parabola. And this shape is literally everywhere. It's the path of a basketball, the curve of a satellite dish. Now, the most important point on any parabola is its vertex. That's just the official name for the turning point, the very bottom or the very top of the U.
And graphing these isn't as scary as it sounds. The most basic parabola, y equals x squared, has its vertex right at the center, at 0, 0. So what happens if you just add a number at the end, like y equals x squared plus 5? You're not changing the U-shape, you're just picking the whole thing up and moving it 5 spots. The new vertex is just at 0, 5. Simple.
Horizontal shifts are just as easy, but there's one little catch you gotta remember. It works the opposite way you'd think. If you see y equals x minus c squared, you might think that minus c means move left, but it's the reverse. Here's the trick. Ask yourself, what value for x makes the inside of this parenthesis 0? For x minus 2 squared, the answer is positive 2. So the vertex moves 2 spots to the right.
And there you have it. You've just added a powerful set of skills to your mathematical toolkit. And trust me, this stuff is absolutely essential, not just for tests, but for all the math that's still to come.
So let's do a super fast recap. You now know how to use FOIL to build quadratics. You can break them back down by factoring, which is just our reverse FOIL puzzle. You can find the roots to actually solve the equation, and finally, you can visualize it all by graphing the parabola. Build, break, solve, and draw. You got this. Look at what you can do now. You can construct these expressions, you can deconstruct them to find their secrets, and you can draw a picture of what they represent. You are in complete control of quadratics. So the only question I have for you is which one of these new superpowers are you going to use first?